Hi, this video is on integrating by parts. So let's take a look at the formula. Here's the starting point. You integrate part of it you call U, the other part of it you call dV. And when you have a U, you can then also find du. Here, if you have dV, then you can also find V, right? To get from U to du, you differentiate, and to get from dV to V, you integrate. And that's all we need. We put U here, we put V here, V and U here, then we integrate this again, and then we end up with our answer. So just remember, we're integrating U dV, and then it turns into this form. And here's a couple of tips. Let dV be the most complicated part. And that's all you really need to know. Let dV be the most complicated part. dV also includes the dx of the original integral. Okay, so let's take a look at this problem. So we need to call U, remember, here, let me write the formula up here for us again. U dV then it changes to U times V minus integrating V du. Okay, so it said let dV be the most difficult part. So let's call that dV, and let's call this U. So if U equals X, then the derivative of U equals 1. The derivative of X is 1. If dV, by the way, another way of writing the derivative of V, right, is V prime. If V prime, in the same way here, du is U prime. If V prime equals, or dV, same thing, equals e to the x, then if you integrate e to the x, if you go to your integration form, integrating e to the x equals e to the x. So we have dV, we have V, we have U, and we have du. So I can just plug this into the formula now. The formula is U times V minus the integration of V du. So U up here is X. V down here is e to the x minus the integration of e to the x V, and du is 1. Okay, so 1 times e to the x is e to the x. When you integrate e to the x, you just get e to the x. So we're done. Oh, by the way, when you integrate e to the x, don't forget there's a plus c after it, a constant. So we're done. This is our final answer. When we integrate this, we get x e to the x minus e to the x plus c. So all we're doing is plugging, finding this u, finding this dv, differentiate the u, and integrate the dv. Get these four parts, and we should be good to go. Let's try another one. Okay, so let's put that formula back up. U dv changes to u times v minus integrating v du. Um, Here, I don't think it matters. I can I can do both of these. I think it would be harder to integrate ln x. The derivative of ln x is really easy. So I'm calling this dv, and I'm calling this u. Right? One has to call u, and one has to call dv. So my u is ln x, and the derivative of u is 1 over x. The derivative of ln x is just 1 over x. So my dv, and don't forget dv is just another way of saying v prime, is x squared, and dx. Don't forget that dv has to have that dx with it also. So this prime is x squared dx. And if I integrate that, v becomes adding 1 to the power and then putting it on the bottom. This is what v becomes. There's v, there's u prime, and there's v prime. So I'm going to plug all these into the formula. U is ln x. V is x3 over 3. Integrating v, x3 over 3 times du. And du right here is 1 over x. Just want to make sure I use u prime instead of du. It's the same thing. So I like to put the power in front there. So I have x3 ln x over 3. One of the x's here cancel. So I'm really integrating x squared over 3. And so now I'm going to integrate this, add 1, and I get x3, put the new 3 on the bottom. Since there's a 3 already, it's 9. And don't forget the plus c after it. So I'm left with this x3 ln x over 3 minus x3 over 9 plus c. All right, let's look at the last problem. And here we're integrating from 0 to 1. Now, if you notice, we have arc sine x, and there's no second term that's multiplying. We can use a 1 in front of this dx for the second term. So I'm going to call arc sine x u, and I'm going to call this the dv. So if u equals arc sine x, then du if you look at your formula sheet, the derivative of arc sine x is 1 minus x squared. If dv equals 1 dx, then v integrating a constant of 1 just becomes x. So my formula is, once again, it's going to be uv minus integrating v du. U up here ends up being arc sine x. V is just x. Minus integrating v, which is x. And du is 1 over 1 minus x squared. So on the side, I need to look this up if I have this on my formula sheet, x over 1 minus x squared. Okay, so I'm at the point where I want to integrate this. It's going to get a little messy, so I'm going to go to another page here in a second. Another way of writing that, by the way, I think I wrote it wrong. There should be a square root here, right? If we look right there. So there should be a square root symbol here. Okay, so another way of writing this would be then integrating x to the 1 minus x squared to the negative 1/2. And if I call the bottom u, if I call this is the same way as doing x over the square root of u, right? Or x times the square root of u. I'm calling 1 minus, God, I'm running out of room here. 1 minus x squared, I'm calling u. So du would be a negative 2x. Do you see? So I can actually change this integration because I have to do u and du. I have to have a u and a du in here. This is close to the du. I just need to put a negative 2 in front of it. So if I put a negative 2 in front of that x, let me change the color of it. Do you see? If I put a negative 2 in front of that x, then I have to put a 1 over negative 2 a negative 1/2 in front. Do you see how they were cancel out now, and it will just be x? So this is my u, this is my du now. So I'm going to go to the next page. So just remember, I now have this in a good integration form because I have u du. So it'll integrate really nice and easy now. Don't forget I have this arc sign in front over here. So I'm going to go to the previous page. And so don't look at this. In my problem now, I do have the x, arc sine x. And then we have that minus, and then a minus 1/2 integrating 1 minus x squared to the negative 1/2. And we do have a the minus 2x with it there. So I'm going to put the minus 2x with, well, there, you can put it over here. This is the minus 2x. This is the u, and this is the du. If I bring this minus 2x out in front, well, that's the u and the du. By the way, when I don't bring the minus 2x out in front, that's why I have the 1x there. This minus minus changes to a plus. X arc sine x plus 1/2, integrating 1 minus x squared to the negative 1/2 minus 2x. Once again, this is u to the negative 1/2 and du. So if u is, do you see u equals 1 minus x squared? So then I'm actually integrating. I'm actually integrating u to the negative 1/2. I add 1 to that, and I end up with u to the positive 1/2, negative 1/2 plus 1, and then I put 1 over 2. So when I integrate this part here, I end up with 2u to the 1/2 over 1, and there's just 1/2 outside. These cancel, and I'm just left with u to the 1/2. And don't forget, u is 1 minus x squared, and 1/2 is the square root, so I got 1 minus x squared x arc sine x plus the square, oh, and don't forget the plus c. So this is the answer that I have, Lord, and I ran out of room again. Don't forget, we have to integrate this from 0 to 1. So now if I put 1 into the function, just put a 1 everywhere you see an x. At first, 1 times arc sine of 1. By the way, on your calculator really quick, take the arc sine of 1, or you can use your, you get pi over 2. So 1 times pi over 2 is pi over 2. I'm sorry, I'm really messing this up because I have no room here. So when I plug 1 in, by the way, you plug 1 in down here, you get 0. So when I plug 1 in, I get 1 times arc sine of 1. Which is really pi over 2. 1 times pi over 2 is pi over 2. And then we subtract and put 0 in. If I put 0 in there, I get 0. Put 0 in here, I get the square root of 1, which is 1. So my answer is pi over 2 minus 1. So that's the answer, unless they want a decimal answer. And if I can put it, it's approximately 0.571 on your calculator, or you just leave this as an exact answer. Sorry for that one being really messy. I really need a lot of paper on that to do that. But the whole process is the same. The hardest part is integrating this and realizing that this is u, and then du. If 1 plus or 1 minus x squared is u, then du is a negative 2x. And somehow I have to put a negative 2 into here. So I have to put a negative 1/2 outside to cancel those out. And then the integration becomes easy. And there is one more slide. I just brought this slide up from the book. Um, this slide just shows some common integrals using integration by parts. If you have x to a power and then e to a power, or x to the power sine, x to the power cosine, it tells you, if you have x to a power, use that as u, and the sine or cosine or the e, use it as dv. So that's kind of cool that they tell you, hey, if you're going to come across one of these, use the u as x to the n. By the way, sometimes it doesn't matter if you use u or dv for problems. They just telling you it's easier if you use these. Same way with here, x to the n, ln, x to here for ln, arc sine, and arc tangent. It's easier to make the sine, arc sine, arc tangent, and the ln the u part, is what they're saying. If you just have sine, cosine, or e, it's easier to have those parts dv. And then here's another one. Once again, just plain, if you have e, see, this that gets crazy. If you have an e with a sign, up here we had x to the n with an e, x to the n with a sign. If you have an e to a power and a sine to a power, it's best to make the sign the u, and then the dv would be e to the power. So I would take a look and have, if you're doing problems similar that look similar to these, have this formula sheet in front of you so you know what would be easier to label as u or du. I mean, u and dv, and then you'll integrate after that. Give me a call if you have any questions. Let me know if you need anything. You guys have a great